Hello everyone. Today we are going to look at the second part of chapter 23.1, and I just realized that I forgot to write part 2 here, so let's put it in, part 2. And this section is on parallel circuits. So our targets today are to compare parallel series and simple circuits, and we want to apply Ohm's law to parallel circuits. So our essential question: what are the similarities and differences between simple, series, and parallel circuits, and how does Ohm's law function in a parallel circuit? All right, so let's review, because this is where we need to know in order to go forward. So Ohm's law, this should mean something to you, right? Ohm's law relates current and resistance and voltage, and we usually write it as I equals V over R, but of course you could rearrange that formula if you would like. Our second review is the characteristics of a simple circuit. So remember that a simple circuit has one source, one device, and one path. All right, so you have something like a flashlight. It's either on or it's off, one of everything. Our third review here is the characteristics of a series circuit. So a series circuit has one or more source, has two or more devices, and still only has one path. So remember, this is the circuit where everything's on or everything's off. It's an all or nothing kind of thing, okay? So now when we look forward, we're going to see the similarities and differences between simple, series, and parallel circuits. So here's an example of each, and I want you to take a few seconds, and I want you to look at those and see what you see as the same and different between each of those types of circuits. All right, so what is the same here? Well, what I see is the same is that each of those circuits is a complete circle, right? So each of those circuits is going to function because the current can get all the way around. I see that they all have a source. I see that they all have at least one device. And I see that they have a complete path. We kind of already talked about that, okay? So that's what they all have in common. They're all complete circuits. They're all going to work. The simple and the series also happen to have a switch, but we know that a switch is not necessary for a circuit. Okay, so what's different between these circuits? Well, what do we know? We know that the simple circuit has one of everything. All right. What do we know about a series circuit? A series has two or more devices. That's the biggest difference. And what do we know about parallel? Parallel seems to have, well, let's see. What do you see? There's still a source. There probably could be more than one. There's still two or more devices. But the biggest difference here, can you see it? A path for each device. Okay, so when I look at my parallel circuit here, I can see that there's a path for this device, and there's also a path for this device. So if I call this A and I call this B, I can see that there's a path for A and there's a path for B, and they operate independently of each other. All right, if I were to add a third lamp out here, I could add a third lamp just like this, and there would be another path. I should probably change colors. There would be another path for lamp C out here, right, that would go all the way around. Okay, so that's the biggest difference, is that there's a path for each device. So let's be specific. What are the characteristics of a parallel circuit? A parallel circuit has one or more sources, just like a series. A parallel circuit has two or more devices, again, just like a series circuit. And here's the big difference, has one path for each device. Now, what do you think that means? If we go back up here, if something happens to light bulb A, are B and C still going to light? Now, in a series circuit, right, if lamp A goes out, everything goes out. Is that also true in a parallel circuit? No, it's not. Good for you. Because, I guess I need another color. This is really getting messy. If lamp A goes out, there's still a way for the current to get all the way through B and all the way through C, right? So if lamp A goes out, B and C are still going to light. If B goes out, A and C are still going to light. If C goes out, A and B are still going to light, right? There's always another way for the current to get around. So that's important. All right. So your turn. Stop the tape, or the video, and I want you to identify each circuit down here below. So there's 8 of them. Your choices are not a circuit, of course, if it's not even going to light, series, parallel, or simple. Okay, so stop the video and go ahead and do your turn. Okay, how'd you do? Did you get them all? Of course you did. So let's look at essential question number 2. How does Ohm's law function in a parallel circuit? Well, we still have to be able to find the equivalent or the total resistance. All right, but in this case, in order to find the equivalent or the total resistance, we are going to have the sum. Remember that sum means adding, right? Of the inverse of each resistance. What does inverse mean? Inverse means 1 over. So the sum, that means we're going to add, and the inverse means we're going to do it upside down, right? 1 over, oh, there's no T there, I'm sorry. 1 over each resistance. So what does that look like? Well, if we write that as a formula, we have 1 over the total is equal to 1 over RA, or you could call it R1, 1 over RB, or you could call it R2, 1 over RC, etc., etc., etc. Okay, so the sum of the inverse of each resistance. So how would I find the current then in a parallel circuit? How would I use Ohm's law? So step 1 is going to be to find the total resistance, just like we did before, and step 2 is going to be to use Ohm's law. And just in case you want to write it again, Ohm's law, I equals V over R. Okay, so here's our example problem. I have two 25 ohm resistors connected in parallel with a 120 volt source. So the resistors, I need to know they're in parallel, and it's 120 volts. So here's what I know. I have RA, or R1, whatever you want to call it, 25 ohms. I have RB, also 25 ohms. I know that it's a parallel circuit. That's important. And I know that my voltage is 120 volts. Okay, A says draw a diagram of the circuit. All right. So here's my battery or my source. oh, I don't know that it's a lamp. All I know is that it's a resistor. Okay, so there's RA. There's RB. We'll put our numbers in here. That's 120 volts. This is 25 ohms, and this is also 25 ohms. All right, so there's my diagram. Then it says, calculate the equivalent resistance in the circuit. All right, part B. So I'm going to have 1 over R total. In this case, I only have RA and RB, so that's what my formula looks like. I'm going to plug in everything that I know. 1 over 25 plus 1 over 25. Now, think back to grade school, okay? Remember, when you add fractions, you add the denominator. You add the numerators. So 1 over RT. 1/25 plus 1/25 is 2/25. And this is fine, great, except we're not done, because I don't want to know what 1 over RT is. I want to know what RT is. So here's how we're going to do this. We're going to cross multiply. So I'm going to do 1 times 25, and I'm going to do 2 times RT, and then I'm going to divide both sides by 2. This all looks familiar to you. And I'm going to get 12.5 ohms equals RT. Now, if you don't remember how to do that from grade school, go back and listen to that part again, because you're going to have to do this a lot. Okay? And then for part C, we're going to use Ohm's law, because part C says calculate the total current. So I'm going to have 120 over 12.5, and that is going to give me 9.6. What are we going to label this? Amperes, because this is current. Okay? So we found the total resistance. It's a little bit trickier than it is with a series circuit. And then we plugged that in. Whoops, I can't get this. There we go. And then we plugged that in order to find the total current in the circuit. All right? So here's the your turn. There are 4 parts to this, and I want you to make sure that you write down any questions that you have so we can talk about them in class next time. And I will see you soon.